The robotics project is a project that I give students every year. And the reason that I give people the robotics project is because at the very start of the term, at the very start of this topic, I talk to students about engineering. Because that's what it is. It's engineering maths. And I have to say, I think that we've done the maths part pretty good. But the engineering part is a bit so-so. The reason that I think the problem is with the engineering part is that in order to properly teach engineering, I need you to go through the engineering process. And I think the really important thing with the engineering process, in order for you guys to really appreciate it, is I need you guys to build something. Why? Because when you build something, you need to go through the engineering process. You need to prototype. You need to plan. You need to prototype. You need to ask. You need to research. Then you need to build something, and then you need to evaluate it. You need to fix it, and then go back and re-prototype and refix it. And that's what engineering is really about, is making a solution, building something that is a solution. Now, I could give you a problem to do with, I could give you I could give you a programming problem. I could give you a design problem, which is an engineering one, and I could give you a something even like just as a website, design a website. That would be another engineering thing. But in fact, I think the best project, or perhaps the most fun, would be a robotics project. Robotics are interesting because they combine three things. They combine coding with they provide coding with electronics with design, and that all of these things come together to bring you robotics. So it actually brings multiple different avenues. And what I love about this project is there are multiple different ways for you guys to show off your skill, right? So what we're going to do today is a quick introduction to the project. What is the project that we're going to be doing? What is the goal of the project? And so on and so forth. Now, when I started making this topic, right, back in the good old days of 2018 and 2019, actually even earlier, the first time I did this project at the school, it did engineering maths at the school, was 2017. In 2017, I got students to build a bridge, but I got them to build a bridge out of power pop sticks. And it was a big project, and the whole point of it was that I wanted them to build this bridge out of power pop sticks. And then at the very end, what we did was we tested it. So what we did is we got some heavy masses, and we hung those heavy masses off the bridge until eventually it broke into a million pieces. And the thing is that this project actually worked pretty well, but I hated it. And the reason I hated it is because of this, the final thing at the end. At the end, the students had a broken bridge, and I couldn't really. And so I asked students, what would you do to improve it? And they said, oh, I guess we'd add more paddle pop sticks. Maybe we need to add more paddle pop sticks like to this section here and this section here. But the problem is that I couldn't tell them to test that out because their bridge was now in a million pieces. So it didn't feel like the proper engineering process. It felt like students were like, hey, cool, I built this cool thing and now I destroyed it. I didn't get to watch students, challenge their ideas, or, I didn't get to see students challenge their ideas or try new ideas and justify choices, because how can you justify if something's a good choice or a bad choice if you only got one piece of data? So what I decided to do instead was I decided to get students to make these. These are little cars. And I wanted to get these little cars to have sensors on them, and so that they could sense walls and things and so on and so forth. And it actually would have been pretty all right to do, except we didn't have a lot of time to do it. And the software that we're using was a bit challenging. So what I was getting them to do is students built robotic rovers. It was time consuming. It rarely worked. So even though I have like 8 groups, usually only 3 would actually get something that moved. But it was fun. So what I decided to do was I decided to change projects. I wanted to get rid of this one that I've been doing. And I got rid of it last year in 2020. And I wanted to do something brand new. And the reason I wanted to do something brand new is because the reason I didn't like this project, this was an improvement, right? Because now students could, and I really should add this here, students could check and then redesign. If their project didn't work because their code didn't work, they could try new code. If their electronics didn't work, they could try new electronics. And so then they could get closer and closer and closer to a good design. But then I decided to change it. I'm like, why the heck did you change something that was pretty cool? Also, by the way, not only did this involve electronics, it did involve 3D printing. These chassis are 3D modeled and then printed by the students. So these are their models. So what did I change it to? I changed it to this. This is my workshop. And you might look at my workshop and you say, ladies and gents, easy question for you guys in chat. What is on the desk? What is on the what is on the workshop? So I messed with Lego Robotics. That's still something. A locker door. Yes, hey, a locker door I borrowed permanently from the school. Not stole. Stole is a dirty word. I didn't stole. I repurposed it. I recycled it. Yeah, you know what? Yeah, suck on that, Brian. I recycled it. This was going to go in the bin. I recycled it. So, what is the point of this locker? Why did I recycle a locker door for? What was the purpose of it? We're not going to make 3D printed guns, Andrew. Why did I recycle it? Because I want you guys to make this. This was my idea. It is a Arduino, or the same type of one that you were working on the other day, but it's connected to a servo motor. And what that servo motor is doing is it's turning the lock. So the servo motor is turning the lock. If you actually look, it is opening and closing the locker. If you even look at the top, there it goes, up and down, and up and down. So I was pretty proud of this when I got it working. So, because I was like, hey, cool, look, it works, yay. I'm not a complete failure of an engineer. So, and there's the code running it. So the code is plugged into the computer and it's running it. So what is the purpose of this? The purpose of this code, yeah, I know, I thought it was pretty cool. But why did I make this? It's like, okay, so I can do, let's just do this. So I have so what I have is I've got a program, I've got a code, and the code, what does the code do? The code runs a motor, and the motor opens and closes a locker. Now that would be fine. That would be an interesting project to do. But I wanted to add one more thing. So what I did, ladies and gents, is I ordered from the school, I ordered for the school some RFID scanners. And the purpose of the RFID scanner is the RFID scanner could run the code, and the code could run motors, and the motors could open and close the locker. Now, why? And that was the cool part. So this is essentially what I designed. I thought, let's get this. Get an RFID chip reader, which talks to a microcontroller, which then does some code, which tells a locker door to open and close. Now, why? Why did I design? Why do I think this is a good project? Yes, RFID, that's the new technology. Why did I think this is a good project? Right, I want you guys to suggest in chat. Why do you think having an RFID locker, RFID to open a locker, why do we think this would be a good, what is this a solution to? Tell me, that's a solution. What is the problem? Tell me, what is the problem that leads to this? I'm going to give you guys a minute to write this in chat. I'm just going to grab something. But yeah. So let's see, what are our suggestions? What is problem this solve? What problem? Because you can send RFID signals to open it and you don't need to physically touch it. Yeah, that was absolutely not the point. That was not the reason that I was suggesting. But you know what? Thank you, Andrew. You gave me a whole brand new justification for doing this project. So contactless opening. And that's important in the land of COVID. What's another good thing about this project? Why do we think it's a good thing to have an RFID, using an RFID chip? What else? What other reason could I have? Anyone got a suggestion? Sort of. Let me show you. So the reason why I'm going to do this for a second. Yeah, exactly. But there is a reason that I chose RFID. The reason, ladies and gents, that I chose RFID is because RFID, there is an RFID chip in these. This is my staff ID, but you guys have an RFID chip in your student ID cards. So my logic was that if you could use your ID, student ID, to open your locker. What problems does that solve? Why would it be a good thing for students to be able to open their lockers with their ID rather than with a rather than opening it with their what word am I looking for? Why would it be good to open it with their lock, with their ID, rather than open it with a padlock or a with a thing? Yep. Just in case you forgot your password. Well, sort of. Exactly. I like this. First one is Andrew, good suggestion. Security is a good reason, because now there's only one person that can open up the locker. One problem that we had is we had a lot of people that would share their, and it still happens now, is people share their locker combinations. It is more secure than a standard lock that can be broken or opened. The universal key has the Genesis hat. Thank you. Universal key, I like that. The other reason that I was going for is that it can easily be changed. So you can easily change one locker for another locker. So there are lots of little problems that can be solved. You can easily change it. And the main reason that I brought this up is, I'm not sure if you guys remember, but last year we had, and this was really, really bad, we had 10 lockers, we had 10 mobile phones stolen from lockers. And that was because students had no lock or didn't lock their lockers. I like to think that the reason that they didn't lock their lockers is because it was too hard. So the reason that this, the other reason is that it's too hard to open it with a code. Imagine how easy it would be with just being able to scan an RFID. So we found 1, 2, 3, 4, 5, 6, 7 reasons why this could be a good idea. So that's the reason why. It gives you guys a chance to do this, and it's a real problem. That's what I liked about this. This is a real problem. You guys can actually go back and actually speak to people who say, yeah, we've had lockers broken into. If we go back, this is cute, and it's, you know, cute little cars. And it is a harder project, but it doesn't really solve anything. Yay, cool, we made a robotic car, so what? Here, we make a locker that opens with an RFID chip. That's solving a real problem, and that's what I like about it. It's solving a problem. It's solving the problem of students not locking their lockers. It solves the problem of security. And it solves the problem about it being easy to change. One of the examples that I give is that, like, the universal key, imagine now you just have to tap a special card and you can open up all the lockers in case you need to, in case there's like a bomb or something in a locker or something. So there are so many things I can see there'd be really good reasons why it would be. I can see that there would be a lot of problems with this solution, but we're not going to talk about the problems because we're going to pretend they don't exist because we've got this project. So what time is it? So what I'm going to do now is I'm going to spend a little bit of time talking about the parts that we're going to use. Have I got, actually, you know what, before I do that, are there any questions about, So the goal is going to be that you guys are going to be working in groups to design something like this. You're going to have some people that are going to be really good at the coding part. They're really good at making code. You're going to have some part people that are really good at the electronics. And you're going to be working in groups of 3, because then that means if someone's absent, then we've always got some people, 2 people in the group to run through the project. Now, I'm going to warn you guys, this project is very difficult. There are lots of challenges. What I've found that the 2 things that that I see most is I see in students is I see this. I see perseverance, which means to keep going. And I see a lot of students hit a lot of difficulties in their row. They hit a lot of speed bumps in their path. And the real challenge is the real ones are the students that make it to they keep pushing on even when they're struggling through a challenge. The other thing I see a lot in this is problem solving. And I find this project really gets you guys to try and learn how to solve problems, even if you don't know what the solution is or how to get to a solution. Now, not all of you guys will have success in this program. That's okay, though. It's all about the learning process. Now, let's talk about the robotic. Yeah, so are there any questions? Have you guys got any questions so far? Any ideas, any issues, anyone excited? Have I got any points that you guys want to make before I move on?
Wait, so how are we supposed to do this? Like,
what do you mean? How?
Like the locker. Like how are you supposed to like do it?
Are we gonna do it like when we return to school?
So the plan is, yes. So the plan is, Andrew, you've got to, yeah. So the plan is we're going to be working on this when we go back to school. Today's lesson is to get a lot of the basics out of the way. Hopefully, oh my God, hopefully, we will be back at school next Friday and we can start working on this project next Friday. If not, I'm going to have to come up with a whole brand new bloody engineering maths in lockdown program. But I still can probably do like the 3D printing part, maybe, if worst comes to worst tomorrow on next Friday. But let's just hope that we can come back. As for the building part, obviously I'm not going to get you guys, all of what you guys will be in charge of is wiring up this circuit to this and the code. You guys don't have to worry about 3D printing this or how to attach it to the locker. All I care about is you guys can actually do the hard part, which is essentially this part here. Now, we're not going to start on this part. We're going to build up to it, but I just wanted to show you guys this part. This is our end goal. So we're going to be building robotics out of these things. We're going to be using a red board. A red board is, by the way, is the same as an Arduino, which is the same thing that we worked on when we went on that excursion. An Arduino, for those of you that don't remember, is like a mini computer. It has a CPU. It has some RAM. I think this is the RAM, but I might be wrong. RAM is, of course, short-term memory. And it has slots. And these slots here is where you put wires in. So you will be putting wires into those slots. And it's also got this. It's got these two are input ports. And so you can input power into those ports, or you can put a computer in there. So that's what a red board is. What I'm going to do is give you guys, what about the little bit more detail? On the right, there are something called 13 digital pins. It's actually 14, so my bad. There are 14 digital pins because you got to count 0, but still. There are 14 digital pins. Some of these pins have a little wavy line. These are called PWM pins. PWM pins can send out different amounts of power. So instead of sending out otherwise, they can only send out 0 volts or 5 volts. They're the two things that can come out of these pins, unless you use one of these special pins. On the left, you've got analog pins. They take in analog signals. So they can take in a voltage between 0 and 5 volts. So you guys can use those to detect, oh, well, these can be used to detect, we've got 2 volts coming in, this is 3 volts. This allows you to make dimmer switches. And on the left, we've also got our power source. So we've got 5 volts power, 3.5 volts. And then we've got, let me do these in pink. Have I got pink? Oh, I don't have pink. We've got 5 volts power and 3.5 volts as well. And then we've got GND. Now GND, this is like the negative side. And the power is like the positive side. So that's where you'll be plugging your circuit into. And we're going to be using breadboards. Breadboards are you guys have had some experience with breadboards now. A breadboard has one big long line, one big long line of negative. You've got one big long line of positive. And then each of these forms their own lines. Is GND the ground pin? Yes, GND is the ground pin. It is the same as a negative. I say negative because I'm not sure if you guys, I'm not sure if you guys know what ground or grounding something means. I do teach it in year 11 physics, but I don't teach it to you guys. So, but it just means the negative or where the electrons want to end up at the end. So that's, we're going to be using breadboards, and we're also going to be using a bunch of other components like resistors, LEDs, motors, speakers as well. Yeah, we've got a lot of things we're going to be using. So how does a breadboard work? You might be looking at this and being like, why is this LED on when there is nothing attaching to it? Well, that's because this LED has wires that connect different parts. So my guess is that, oh, by the way, there's probably another wire here that I cut off, my mistake. So you've got a wire that goes up here that connects to this, a wire underneath the breadboard here goes up through the LED. Oh, this is an LED. So that means the LED is pointing this way, through the LED, back through this resistor, and then up and then out. So that's how you can think about this. It does make a circuit. The main thing is that these lines are left to right, whereas these up and down ones are all connected. This one's not lit up. I imagine it's because the LED is in the wrong way. This happens all the time. Students come up to me and they say, "Sir, I connected it just like you said." But yeah, but you also can see is that this one here, it's going from a negative line back to another negative line. So that's probably not going to work either. The other things we're going to be using aside from breadboards are servo motors, which are just like motors. They're just special kinds of motors. And we're going to be using an RFID scanner. That's going to be allow us to read your student ID chip. So yeah, all of you guys have a student ID chip in your card. That's what allows you to use the printers at the school, because you can tap your card. So all I'm doing is saying, well, we've already got scanners at the school. Let's use them to open and close lockers. And the main thing we're going to be doing is we're going to be getting a code, putting it onto a through a cable into our Arduinos, and that's what we're going to be doing. Now we've reached 12 o'clock, so we're going, well, pretty much. And then I'm going to ask you guys to download the relevant one for you guys. For most people, it will be Windows 7 and newer. So just click this top one. Don't do this one. This one's crap. But some of you guys that are using Mac, I'm going to get you guys to do this. When you click on this, and I know that you're not listening, Raymond, so I'm just making sure that you pay attention. Click on the just download button, because always I get someone to say, "So do I have to pay for it? Do I have to pay for it?" No, you can just click the just download, and because you're students, that's okay. Why am I picking on Raymond? Because he always asks me something after I've announced it. So no, you do not need to pay for it.
Wait, which one do we download?
You download, well, okay, who's asking you that? Is it you, Brian? Brian, have you got a Mac or have you got the Windows machine?
Windows.
Well, then you click on the top one.
Oh, okay.
If you are using a Mac, which, you know, is disgusting, you should feel ashamed of yourself.
Yeah.
You click on Mac OS X at the bottom. But for everyone else, just click on that. You click on just download and it will pop up here, and then you can run it when it opens up. I'm actually going to run it because I have to download a new copy of the software. I know, right? Imagine using Mac. Now, this is so good. This is one of the rare times that I'm like, oh my God, thank God that I've got all of you guys at home. Because I get students to do this in class. And you know how crap the internet is at school? It's so crap. And then they go, "Sir, I'm still waiting for Arduino to download. It's going to download in like 10 hours. I'm like, really? Whereas because you guys are all at home, I'm hoping that it's actually not going to take you guys very long. Maybe it might take a little bit for some of you guys because, you know, you're and you might not have good Wi-Fi, but for me, I'm going to be done in about 15 seconds. You guys might take a little bit longer, but if you do take a little bit longer, you can work on it after school. Yeah, so the Liberal government is terrible. That gives us terrible NBN. There we go, install. Whoopsie, okay, here we go. I'm just going to install it real quick.
Hey,
So you guys,
sir,
yes,
do we download this on a device we use at school?
yes, that's the one.
Oh, shit.
Because we're going to be using this at school. But yeah, you don't need to install it right now, but you can. You can install it now. You can install it later. It's up to you. Okay. I'm going to install a new copy of it because my old one was out of date. Yeah. Yeah, you can install it later on. If you haven't got it on, it's okay. So I'm just doing this because I'm just seeing how long it would take you guys to do it if you guys had internet as good as mine, which I imagine some of you guys do. Some of you guys probably have worse laptops, worse computers, so on and so forth, which is fine. I just finished downloading it, so it's done. Cool. So that's something that you guys can do. Yeah, later. What does the program look like? Let me see if I can show you what the program looks like. At the moment, the program should look like this. And at the moment, this is the program that we're going to use to connect to our Arduinos. Now, oopsies, I've shared the wrong screen. Now, this is what the program would look like. Obviously, it doesn't look like much now. I can verify the sketch and it will tell me that the sketch is fine, but there's not much here to talk about. I'm just showing you guys, and then what you would do is you would upload, you push this upload button to upload it to the Arduino, but it goes, hey, an error occurred. Why? Because there's nothing connected to the computer. So duh, of course it's not going to work. But I'm just showing you guys that's what it would look like. Now, whoops. So, Andrew, are you using, by any chance, Andrew, have you got a Mac? I have to admit, Macs are annoying. Macs are slightly better at this program, which annoys me, because I think but actually I think the new version is okay. Because the problem is the old version, you couldn't actually connect to your the Arduinos. You have to download some drivers, and that's something I would have to definitely wait to do at school, because you guys can't download the drivers without having the actual Arduinos. But the next step is, but I think the newest ones do download the drivers for you, which it would be amazing. I would love it if it did that. But let's not worry. So this is the program that we're going to need to get to talk to the computer, to talk to the Arduino. Now, in the past, I've actually gotten students to download this and work with it straight away. But I'm going to get you guys instead, we're going to try to use a different technique. I'd like you guys to try and use Tinkercad. Now,
So what kind of programming is this?
This is C# or C+ programming.
Let's go.
Let's go.
What I'm going to do, I think for this year, where is it? For this year, what I'm going to do is I'm going to do this, right? I'm going to make available to you guys the C# code that you. So for the ultra nerds here, I'm going to do it in two ways. I'm going to do for the ultra nerds essentially this. Where is it? So this here is the code that you would be expected to put in, right? But I know that for some people, this might be a bit daunting. This is specifically, it might not be exactly C# code. It is based off C# or C+, but it's, you know, it is pretty much C++, but it's got some minor differences to it. But I know for some people, this might not be the kind of coding that you're familiar with. So what I've actually discovered is there's another way to do this type of coding. I wanted to try that out. So to do that, I'd like you guys to go back to the where are we? Go back to the classroom. And then I want you guys to click on Join Tinkercad Class. Now, when you join the class, what it will ask you, actually, what it will ask you is it might ask you for a code. The code that you need to put in is your student code. And that should, and I'd like you to create a new circuit. And you should get a slide, a page that looks like completely blank. And the first thing we need to do is I want you guys to put an Arduino in the middle. And then a breadboard up on top. Like so. So see if I want you guys to see if you can get that. Now, can I see how you guys are going? If I duplicate this, by the way, you might want to name this. On this top left-hand corner, you can name it. I'm going to call this first Arduino test. That's what I'm going to call mine. You can call it whatever you want. What I love is I can go to classes and I can see how you guys are doing. Looks like Raymond's figured it out. We figured it out. Nathan's figured it out. Anne's figured it out. Andrew's figured it out. Now he's screwing around with other things. God damn it, Andrew. Next thing I'm going to get you guys to do is let's now open up this section. Andrew's going, I don't know what's going on. Andrew, have you got this far yet? Have you got this far yet? Now it looks like a lot of people.
So what do we do? Where?
He's created 2 of them by, that's okay. Yeah, who's sir? Who's Brian? Brian.
Brian.
You
where's
need
my?
to,
Where?
You need to go to see where it says circuits on the left. You need to then create new circuit. Then when you've done that, you should get on the left, you should be on the right, you should be able to drag some things in. You want to drag in a breadboard and an Arduino. And then you might want to change the name to up here on the top left to say first Arduino test.
Wait, the one that says try circuits?
Yeah, the circuit section.
Where? Try circuit.
Oh, no.
Oh,
nice.
name.
Yeah. New
So
one.
you can, at this point here, let's choose, at this point here, I want to show you this. Let me show you this. I want you guys to click the word code. When you click the word code, you will see this here. This here is block-based coding. Now, for some of you guys, the reason I'm going to show you this is for you guys, this is actually going to be something that you guys are going to be familiar with. So I'm like, okay, cool. Let's do some block-based coding because you guys are familiar with it. But you can also change where it says blocks, you can change it to say blocks and text. In the middle here, we've got block-based coding. On the right, we've got the same thing, but in C# notation. And you can actually go, and this is one of the things that I really, really like, because now you guys can look at this and be like, oh, cool. I can see, I understand what this does. It's on, weight on weight. But for some of you guys, you might not be aware that, hey, digital write high, that's the on part. Hey, look, delay, that's the wait part here. And you can see that all of these parts of the code link to this code here. And what we're going to do is that once we've created this code, right, we're going to, and this is what we're going to do, not today, but when we go back to school, once we create this code, we can then select this code, copy it, and in Arduino, we can, let me show you, paste it. Wow. Where is it? Come on. What? Hold on. In Arduino, which is here, we can actually paste it in and then send this code to our real world board. So that's what I think is kind of cool, and that's why I thought it might be worth showing you guys. Now, if this scares you, you're like, oh, that scares me, you can just leave it on blocks. If this is boring, you're like, no, so give me the real deal, you can go straight to the code and you can start plugging it in. Now, at the moment, this code doesn't do anything very technical. All it does, if I initialize it, is it makes this little LED here blink. But I'm actually bored by that. I want to make like a proper LED blink. So your task is, I want you guys to hook up an LED. I'm going to hook up this LED like this. Let me see if I can put it in. I'm going to put an LED in here. I'm going to hook the negative end to the negative wire, like so. And because it's negative wire, I'm going to make it black. The color actually doesn't matter. And then I'm going to hook this negative end up to the ground pin, which I think is this one here. And if you want to make it look pretty, which I know that for some people this is a massive priority, you guys can do this. Where is it? No. If you double click on the wire, you can add a new joint. Personally, I like to make my wires look pretty, so I like to do this. But you don't have to. And then what I want you to do is I'd like you to take a wire from pin 8. We're going to make it a red wire. Oopsies, no, we're not. Oh, come on. What are you doing? We're going to take a wire from pin 8 and we're going to join it. Oh, whoopsies. Oh no, this isn't going to work. Hey, 10 points for anyone that can say out loud why this is not going to work. What has Mr. Greer forgotten that's really important for
Resistor.
Oh my God, who was that? Who gets 10 points?
It was me.
Ilya, 10 points. I actually didn't think anyone would actually get this right. That's why I said. So let's go. 10 points. You're amazing. You're right. We need a resistor, which is really annoying because that means we have to put one in. So how do we put a resistor in, guys? Well, let's delete this wire. Let's find a resistor. How do I rotate these?
Press R.
Oh my God, who was that? Hold on, I'm having some issues here. Stop. Good. Press R. Really? Okay, let's find out. Let's see if he's right. Oh my God. That's so good. So let's put this resistor here. For those of you guys that are aware, now this resistor connects this line with this line. So this line gets the negative wire. Let's see if you guys can create this circuit. You guys can go backwards and forth to see how you go. So that I need my nickname. I accidentally logged out. And that's why he should have deleted the other accounts. Okay, I see what you mean. So let's see if I can fix that for you. What I'm going to do here, Tin, you'll have to give me a sec because I'm going to have to go over here. I'm going to go here. I'm going to go students. And then I'm going to try this. Tin, where are you? Tin, I'm going to try and do this. I'm going to backspace this and see if it works. Tin, can you see if you can just log in with your first name?
Hey, sir.
Yeah.
Well, why do you need a resistor again?
So we need a resistor so we don't put too much power
No.
into our circuit. Okay, cool, it works. Guys, would you like me to make everyone's login just their first name? Would that be easier?
Yes, very much easier.
Mhm.
All right, I'll do that, but it's going to take me a little bit of time. All right, I'll do this later because there's no point in me doing this now. But let's see how you guys are going. Have you guys had any success? Are you guys struggling? Let's have a look. Circuits. Some people have tried to do it in Andrew and Layla and have tried to do it in the 3D models. You've actually got to do it in the circuits. But it looks like, yeah, so Layla, my guess is that you have gone create new design. So my guess is that you went here. Sorry, if you're still struggling, Layla, this might help. You may have just gone create new design. But this is in the 3D designs. You've got to go down to circuits and go create new circuit. So that's what you should see. It looks like from here that most people, me's okay. It looks like most people have gotten pretty far. Yeah, cool. Glad I was able to help you out. As I said, it looks like as well that it looks like that, I don't know, Ilya, if you figured it out. Did you figure it out, Ilya? Yeah, no,
Nah.
Ilya figured it out.
I don't know.
What's Ilya? Ilya, let's have a look at yours. What are you figuring? How are you going, my dear friend? Looks okay. Yeah, no, you look fine. The only thing you're missing is a wire from pin 8 to the left side of the LED. That's the only thing you're missing. You're missing, if you can see the big
Hey,
screen
sir.
here,
Where's the power coming from?
pin 8.
An 8.
Yeah. So that's what you're
Then
missing.
connect to that. Okay.
So that's the only thing you need to know.
Oh.
But interestingly, guys, and this is
So-
the whole point of this lesson, is that if we do this, it won't work. Let me show you what happened. Whoa. Where's my zoom? There should be a, I bet there is. I say there should be a zoom. I bet there is a proper zoom thing. I just don't know where it is. but we'll just go. Can I zoom like this? Can I go? Oh yeah, I can go
Scroll.
control plus and control minus. Let's do that. If I push start simulation, nothing happens. So how do I get this to work? Well, I need to go to the code and I need to change this. So instead of saying built-in LED, we want to set pin 8, sorry, to high. And then instead of set pin, we want to then say set pin 8 to low. And if all of this works, I should see a blinking red LED, hopefully. And I see nothing. Why am I not seeing anything here, guys? Is it because my resistor is too high? I should have done this.
Do we
I
need to
should.
connect the 5 volt?
You don't need to connect the 5 volt because we're getting 5 volts out of pin 8. I don't know why this isn't working. This is very odd. I might have to figure this out on my own. But even then, I might have to figure this out on my own why this is not working. My only idea is maybe I put this LED in the wrong way. Very much, if this works, I'm going to be shocked. Oh my God, the hell.
How?
Well, because remember, my dear friend, that LEDs have a direction. LEDs have a direction that they go in. I had hooked this circuit up the wrong way. So I was trying to push current through the circuit the wrong way. You can fix this in 2 ways. You can fix this by either using method A, or you can fix this by doing method B. Method B is this one here. By the way, I love this because this is the most common problem the students have, is actually with this type of situation. Can I copy this and paste it? That's what I want to know. I can't really select it. No. The other way you can actually do this is instead of flipping the LED around, you can instead change the direction of the current. So you put this into this end of the resistor, and you put this into this end of the LED. And in theory, this should also work. Let's see. Come on, blinking. Yay! And if you want to blink faster, you can change the speed to be like 0.1 or something. And then upload the new code. So this should make it blink really fast. Yeah, cool. All right, ladies and gents, we're at 12:36. This is a taste of what you guys will be doing, because the advantage is that you guys can design the circuit and then you can build it in real life and be like, oh yeah, cool, this works, blah, blah, blah. So that's what I'm going to try and get you guys to do. I'm going to change the names of you guys now. But what I'm going to do a quick look is to see how you guys went. So did people figure it out? Did anyone get the LED to flash? Did anyone get their LEDs to flash?
Yes.
Yes.
Raymond did. Let's have a look. And who else?
Andrew.
What's
Andrew.
going on?
I'm just asking who had success.
I didn't. Nah.
Oh, poor Brian didn't. Okay, that's okay. Let me see if I can have a look to see. I want to see. Why won't it show me your work? Is it because I'm doing my internet's is too slow? I think my internet's is too slow. It won't let me see who did what. So that's a bit annoying, but that's okay. Ladies and gents, that's the end of the lesson. There's a lot of things going on in this lesson, but you guys now have an idea of what we're going to be doing. You have an idea of how you've accessed two things of the software. I'm going to change it so your login is just your name, by the way, just so that you know. If you didn't quite get the flashing LED to work, that's okay. That's something that we'll work on later on. Otherwise, I will see you guys on Monday.